OP, Q and R are 4 points such that OP is P, OQ is Q, and OR is 3Q minus 2P. Find, in terms of P and Q, first of all, PQ. Well, to go from P to Q, we can go from P to O, and then go from O to Q. So we just need an alternative route. And so P to O would be negative P, and then plus Q. Now for QR, what we can do is go from Q to O, and then from O to R. So Q to O is going to be negative Q, and OR is 3Q minus 2P. So that's going to give me 2Q minus 2P. Justifying your answer, what could be said about the positions of points P, Q and R? Well, we have that PQ is equal to Q minus P, and that QR is equal to twice Q minus P. And that means that QR is equal to twice PQ. So they're parallel, but both contain Q, and that implies that they're collinear. If I could just spell it. Now we're given that OP is I plus 3j and that OQ is 2I plus j. Find the unit vector in the direction OR. So what we're being told here is that P is equal to 1, 3, and that Q is equal to 2, 1. Now we know that OR is 3Q minus 2P. So it was 3Q minus 2P. I'm just going to go and check that. Yep. So that is going to be 6, 3, take away 2, 6, which is 4, negative 3. Or if you like, 4I minus 3j. Okay, so we want a unit vector. This vector, of course, we think about the modulus of OR. It's going to be the square root of 4 squared plus 3 squared, which is, of course, 5. So this vector has a length of 5, and we want a unit vector, so all we do is we do 1/5 of 4I minus 3j.